and everything. So yesterday we did sine law. Sine law, the one I think the key thing to think about is having an angle and the side length across from it, right? That's kind of like forefront of your thinking when you're doing sine law, making sure that you match those up. And we'll talk more about this tomorrow, but that's one of the key ways that you would determine that you're using sine law. Okay, so yesterday everything we did was sine law. You didn't have to think about, do I use sine law? When we did SOHCAHTOA, you had to think about that. You had to think, which one of the three ratios am I using? Am I using sine, am I using cosine, or am I using tangent? Right? Yesterday everything was sine law. It's just, is it a side or is it an angle? So, sine law is pretty straightforward. Today we're doing cosine law. That's the only other one that we need. This is for, again, non-right triangles. And cosine law, as it says here, I hope you copied this down. We use cosine law when we're given three sides. So that's like the triangle on the right. I'm given ABC. Those aren't supposed to be variables or unknowns. They're like the givens. And your unknown would be an angle. Okay? So one of the angles happens to be that top one in this case. That's one of the cases in which you would use cosine law. The other case in which you would use cosine law is if you are given the numbers 4, right? That's what I mean by given. Two side lengths and the angle between them, or the contained angle. We call this the contained angle because it's between the two given side lengths. That's the other case in which you would use cosine law. Every other triangle, if you're given three pieces of information, you can solve with sine law. When you can't use sine law, you can use cosine law. When you can't use cosine law, you can use sine law. There's no overlap. If you're given three pieces of information, it's one or the other, and not both. If you have 4 pieces of information, then it's different. Again, we'll talk more about that tomorrow, but then it's a bit of a different story. But if you noticed yesterday, you're always given, you always have 3 givens, you have to find the 4th. Same thing today, you'll be given 3 things, you have to find the 4th, and it's either or. Can somebody explain why I can't use sine law in either of those 2 cases? Just one or the other is fine. Why can't I use sine law to solve? So if I'm given side length angle, and I'm looking for that side length, or if I'm given 3 side lengths and I'm looking for the angle, why can't I use sine law?
For number 1, there's like you don't know the other angle, like angle A basically, because like it's not across, or angle C.
Yeah,
There's
and
nothing across it,
and so what?
and so you cannot use that.
Because sine law requires that you have at least one pair of angle and side length that are across from each other. And there were those special questions where you're given 2 angles and you can find the third, because you don't have the right angle, but you can find it. You can't do that here. It's not like, oh, these are, I just divide by 2 to get these angles. No, they're not the same. You understand what I mean? You can't figure those out. You can't. So I can't use sine law. What about the other triangle? And yeah, you need a pair and you need at least one angle to use sine law, so sine law won't work. But thankfully we've got cosine law, which happens to work in the exact 2 cases that sine law doesn't. It just kind of turns out that way. So perfect, right? So we've got 2 formulas that we use, and there they are. Okay, so there's the formulas. It's the same formula rearranged. The one on the left is if you're solving for a side. The one on the right is if you're solving for an angle. If you memorize one, you've really memorized both. Like if you memorize one and you use it a few times, you'll just know it. You don't have to rearrange every time. I wouldn't think about them as 2 separate formulas. It's the same formula rearranged. It is a longer-ish kind of formula, and like the quadratic formula, right? It's a bit longer, but again, you were all able to memorize that very easily. Same with this one. It seems long at first, but once you use it a couple times, all of a sudden you realize you've got it. Like it means multiply. A dot. You've never seen that before? I'm sure we've used it at some point, yeah. So a dot is often used for multiply. What does it remind you of? Does it remind you of anything? This formula? Jaden?
Sort of
How's that?
because there's two A.
Ah. Yeah. I see what you're saying. How's that? Equals c squared. C squared equals a squared plus b squared. But then it's got a bunch of other stuff. Do you have a calculator? Do the cosine of 90 on your calculator. What do you get? 0? So if I put in 90, this is 0, which means if I multiply it by stuff, the whole thing would be 0, right? 2 times something times 0 is 0. So if I'm using cosine law in a right triangle, then this part goes away, and it's just Pythagorean theorem. It's actually the same thing. Pythagorean theorem actually is a special case of the cosine law. Very interesting. But Pythagorean theorem was discovered long before this was. But anyway, yeah, so it is kind of the same thing in some ways. But anyway, we don't use this for right triangles, so you don't need to worry about that. Like, that'll never come up. But it is interesting that it means the same thing. Like, it's not just a coincidence. It actually is the same thing. All right, so everybody got those formulas copied down? Again, if you're finding a side, start with the right formula. It'll make your life that much easier. You already know half of it because it's Pythagorean theorem. All you have to remember is the minus 2ab cos c. And then again, once you've memorized one, you've kind of memorized both. Okay, so first of all, we're just going to practice a little bit with our calculators. Here's how I would solve this type. One step to show that I'm going to take the square root of both sides. And you are getting pretty good with your calculator at this point. So I bet if you had to, you could figure out how to do this on your own. But if you want to watch me do it first, that's fine. So here's how I would do it on this calculator. Square root, bracket. And then I just type everything in. There's nothing else to it. Again, on a 2-line calculator, it's just so easy. 14 squared plus 10 squared minus 2 times 14 times 10 times cosine of 35 equals 8.2. Make sure you can get 8.2 or 8.163175 on your calculator. I have this really old one-step calculator in my desk here, it looks like. I'm not sure this is going to work, but if you have a one-step calculator, here's how you would do it. 14 squared. Oh, that didn't work. 14 squared. No, not going to work. Does anybody have a one-step calculator? You have one? Oh, perfect. Thank you. 14 squared plus 10 squared minus 2 times 14 times 10 times, remember you have to put the angle first, 35, then hit cosine, then hit equals, then hit square root, and you get the exact same one, right? Too fast? What? Need a new calculator, yeah. But it seems like it goes by fast, but you already know how to do most of that. Okay, so it shouldn't be too bad. Okay, let's try the next one. We're going to do these two, and then we're going to do two more where you do it by yourself, and I'll come around and help if you need it. I'm going to write this down. Just watch for a minute. I'm going to write this down in a special way. You can write down the question, that's fine, but C equals, so we're going to do shift cos to get that thing. Then we're going to open a bracket. Just watch. Then we're going to open another bracket. This is probably the hardest formula to put into your calculator. Again, it's not really hard. Once you've done it a few times, you just get it. You really start to get how the calculator works. But the first few times, there's a lot of little mistakes you can make. And you need to open two sets of brackets. That's weird. That's new. So that's something that like you've never done before. So you just have to think about it. And then I'm going to do the whole top. And then I'm going to close one bracket only for the top. Then I'm going to divide by. Then I'm going to open up a bracket for the bottom. 22.3, 18, and then close this bracket and close that final full bracket. You have to tell the calculator what order you want it to do these things in. When do you want it to actually do the inverse cos function? When do you want it to divide? How do we tell the calculator in what order to do each step? With brackets. That's what BEDMAS is. Brackets in BEDMAS says do this first. And your calculator knows that. So you take advantage of that by using brackets. So watch again as I do this. And we'll pair up the brackets. Okay, so just put your calculator down, watch if you like. Shift cos, that's the open green bracket. That's the open red bracket. So now I'm going to do the whole top. And just watch, I type it in. 22.3 squared plus 18 squared minus 26.8 squared. Close the red bracket. I'm not closing the green bracket yet because that I still have to divide before I do that, right? That whole thing is in there. So then divided by open blue bracket, 2 times 22.3 times 18. Notice I use times instead of brackets on the bottom. I wrote it with brackets, but I'm using the times. You could do either way, but it's maybe too many brackets if you use a bracket, 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 bracket. And here's something that's interesting. A lot of you probably already know this, but your physical calculator doesn't need you to close the brackets at the end. Digital calculators often do, like calculators online or on phones will give you an error if you don't put in. So there's two closed brackets here, right? Bracket, bracket. That's what I've written on the paper. But if I don't include them, my calculator assumes that's what I meant and it gives me the right answer. Okay, so you should have got 82.6, which is 83 degrees. So let's write that down and you try it. If you got an error, it's probably brackets out in the wrong spot or something like that. So try again. That's probably why then. Shift, cos, bracket, bracket. That's what you have to remember. Shift, cos, bracket, bracket. If you have a one-step calculator, you do the whole top, hit equals. Then you hit divided by. Then you probably have to still open a bracket because your calculator does have brackets. They'll work in this case. Just hit equals. Shift cos. Okay, people okay getting that? 82.6 is correct. 83. Okay, try these two. I'm going to come around and help with any calculator issues.
It's still one step. So it's,
Drop on my neck. You go back to class?
yeah.
Your thing's right there.
Oh, thanks. I still wanna. I can't get the first one. Like the very first.
Okay, so just do 14 squared plus 10 squared minus times. Now you have to put the angle in first, so 35.
Oh, then you times. Oh, okay. And, okay. I said
Then you-
equals adding.
No,
Times
because then it's adding and then multiplying. You want it to multiply first and then add them together. Do you understand what I mean?
Yeah. Okay. There's. I got the right answer. Wait. How do you do that?
No. Oh, that's if you have a two-line test. Divided by bracket. Do the whole bottom. Hit equals. Then you shift goes. It's just the way we did the other one. For this one? Yeah, you're really close. Probably just 28.6, isn't it 26? Which one are you doing? It's not 20, I don't think it's 20. It's 26.8. You're 28.6. Okay, let's take a look. Is everybody getting it? No? Okay, which one are you doing? Okay, so 14.
Which question is that?
Well, wait, which one are you doing? What first one? This first one?
So look, you have to do cosine negative first. And then you put the bracket. And then you put the bracket after.
So 2 times 4 times 7 times 7 first. And hit cosine. No, it's not though, because when you hit equals, it's doing this minus this. But you have to multiply before you subtract. Yeah, 4 squared plus 7 squared minus 2 times 4 times 7 times 4 times 7. Then hit equals, you have to. Otherwise, it's the bed method. Then do the square root. Okay. Here we go. This first one, I want to point something out. A few people are doing this. So, C equals the square root of 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of 70. When you put this into your calculator, if you hit equals there, that's a bedmass error. Why? Because you have to multiply before you add and subtract. This is subtracting this entire thing. If you hit equals, you haven't subtracted the cos 70, right? You're doing it in the wrong order. So you have to do the whole inside part first, and then hit equals if you're doing a one-line calculator, then hit square root. So what do you get for that one? 6.8? 6.8. Okay, next one. Are people done this one? So you got a minute? I'm going to do this one too. It really matters where you get your brackets. If you put your brackets in the wrong place, you get the wrong answer. Like, so usually what we do is we round sides to one decimal place and angles to the nearest degree. 35 degrees, is that right? Anybody get that? $34, you probably typed in one of the numbers slightly wrong, like typed in 18 instead of 19 or something like that. Oh, I see what you're saying. What? It should. So I wrote this out. I wrote it out like this. C equals cosine of 1 of all that stuff. You don't normally have to write that stuff. Yeah, I would just write it like this. C equals. I wrote this to show the order of what you're doing on the calculator. Do you hear what I said? I wrote this so that you know what order to put the brackets in to help us get the order right for the calculator. You don't have to write it every time. You can if it helps you. So it would be C equals cos negative 1 of all of that. That's right. What you've got. It's probably brackets. We'll look at it after, okay? Okay, if you're still having a hard time, there'll be time at the end of the class of the period. We'll look at it again, okay? We're going to try 35 degrees. Let's try a couple in actual triangles now. Solve for the indicated side length or angle, round side lengths to one decimal place, and angles to the nearest degree. So every question you get today is cosine law anyway. But notice how this gives us two side lengths and the contained angle, the angle between them, right? That's what tells us it's cosine law. So even if I didn't know that, I could figure it out. I think it's helpful to start observing that today. It'll help you tomorrow. Okay, so that's one thing. Second thing and we were asking this question when we started sine law as well, if you remember. Are we solving for a side length or are we solving for an angle? I know a lot of you are still writing, so make sure you get the triangle drawn out. So what are we looking for, Liam? Side length. So we want to start with the side length form of the cosine law, which is this one, c squared equals a squared plus b squared minus 2ab cosine of c. And really, it's just sub it and solve. This one's pretty straightforward, pretty easy. It's easier on the calculator, and it's pretty easy in practice. There's not really any tricks. So which one's a and b doesn't really matter. Obviously, those are side lengths, though. The angle has to go in for the angle. If you put 27 in for one of those, that is a bad mistake. Cosine of 27. There you go, more practice. Try again, see if you can get it. If you're still having a hard time with the calculator, let me know. Yeah. Yep. Yep. Nope. You can't. You don't have to. Most calculators, you don't require it. But that's what you're doing is multiplying. So when in doubt, put a multiplying down. And what did you get, Jaden? 8.7. And that's meters in this case. Skira, did you have a question? After we're done, maybe. Okay, we still got a little bit to do here. Didn't work. Any questions about this? Okay. Comment on that one. Let's see. Okay, this one. Everybody got it drawn out? So what are we searching for in this one? What are we looking for? Side length or angle? Angle. And again, notice we're given all three side lengths, so we can't use sine law. You have to use cosine law. So we're looking for an angle, so let's do this. Cosine of C is a squared plus b squared minus c squared over 2ab. Now this one's harder to put in your calculator, and it has a little trick to it when you're subbing in. That is an easy mistake to make. Can anybody predict what that mistake might be and help me out, make sure I don't make it?
4.3 is going to be C.
How'd you know that? That's brilliant. How'd you know that?
Because the theta is adjacent to it.
Very, very good. 4.3 has to be C. Now, be careful. It's not because it's biggest. In Pythagorean theorem, C is always the biggest one because the hypotenuse. Okay, stop writing and look for a minute. That's not the case in this question. 4.3 is C because I'm looking for the angle across from it. If I wanted this angle up here, I would put 3.2 in for C. So if you put the wrong number in for C, it'll work. You'll just find the wrong angle. You'll find this angle or you'll find this angle instead of the one you were asked to find. So you'll still get a bunch of part marks, obviously, if it was on a test. So this is what this should look like. Cosine of C equals minus, I'm going to move that over a bit, minus 4.3 squared. That has to be C, and then the A and B don't really matter. 3.2 squared plus 2.9 squared over 2 times 3.2 times 2.9. And I got shift, cos, bracket, bracket. Divided by? Nope. You gotta do divided by bracket.
Divided by.
Calculators are like $3.
You can get a good one for that. .2 squared plus 2.9 squared minus 4.3 squared equals divided by bracket. You get the little bracket symbol up there? You can't really see it. There's a little bracket symbol. 2 times 3.2 times 2.9 equals second function cosine. This the answer that you got? Uh-oh.
That's what I divided by bracket? Wait.
That's a weird answer. This morning somebody said, if it's 90 degrees, it's a right triangle. We don't need to use cosine law. So first of all, it's not, it's rounded to 90 degrees. Let me put that back up. But rounding to 90 degrees is not 90 degrees. In mathematics, Pythagorean theorem, SOHCAHTOA, it's got to be exactly 90 degrees, not rounded to 90 degrees, right? This to me is an awesome example of like when you know when to round, how to show your answer, how to communicate properly. Even though it says round to the nearest degree, I would probably write this as 89.5 because I don't want any confusion that this is 90. If you wrote, and again, this is why, like if you wrote equals 90, oh, it's a right triangle. No, it's not. That's why we show the rounding symbol, right? So we know it's not exact. You can't use that number as an exact number, but even then, that looks like too close. So, I don't know, 89.5. You wouldn't lose marks on a test if you wrote it as 90, but you gotta show the rounding symbol in that case absolutely, unequivocally, 100% because it's important. I'll come by and check in a second. Okay. Okay. You don't need to copy this down, but I do want you to pay attention, so make sure there's no phones out or anything. Sit back and relax and watch. This is cool, what we're about to do. We did this for sine law yesterday. Sine law was very easy. This one's a little bit trickier. Listen carefully. Somebody asked this morning, do we need to know how to use this? I will tell you, sometimes I put these proofs on tests as bonus questions. I don't know that I will this year, but sometimes I do. So there's that. People always like to know how they can raise their mark. Well, nailing the bonus on a test will help your mark, but bonus is not free marks. It's usually something hard that you have to work for and earn, right? So if you work hard and you go that extra mile, then maybe you can increase your mark a little bit. But also, this is what mathematics is. Like, what we're about to do at first glance is actually not really that bad. It's a little bit of algebra. You're not used to it, but it's perfectly within your capabilities. But this is math, right? We're using the cosine law. Somebody had to come up with it at some point. Next year in grade 11, especially if you take the university course, you will be doing more things like this, what we're about to do, okay? Proving things and that sort of thing. So this is where math is going. So I don't ask on a test, determine or prove the cosine law or derive the cosine law from a triangle. Like, I don't ask you to do that. But it is, yes, something that you should be able to at least follow and be able to think about and be able to understand. So first thing I'm going to do is I'm going to recognize that this whole thing is B, this is A, this is C, and there's a trick that, again, you wouldn't be able to just come up with this on your own. But if I call this distance X, what does that make this distance? I could do that, but that won't help me. It's something a bit better, a bit more useful than that. Anybody else have an idea? No. Good guess, but we don't know that for sure. No. Very nice. B minus x, right? So the whole way across minus the x gives me b minus x. Once I've got that, I'm going to do Pythagorean theorem twice and cosine from SOHCAHTOA twice, and then a little bit of algebra. Okay, so part one, I'll do Pythagorean theorem first. So a squared equals x squared plus h squared. So that was this triangle, the right triangle on the left there, Pythagorean theorem, right? A squared is h squared plus x squared. Everybody got that okay? And then part two, I'm going to do cosine in there. So cosine, what's cosine? Somebody remind me? SOHCAHTOA cos? So cosine of angle C is adjacent, which is x, over hypotenuse, which is a. Okay, part three, I'll do cosine again. Cosine of A is, again, adjacent, so B minus X over C. Little hint, we actually don't need that part, but I just do it because it simplifies things a little bit. And then part four is Pythagorean theorem in the triangle on the right, which is a little bit trickier because of the B minus X thing, but it's still not too bad. C squared equals H squared plus B minus X all squared. Now all I have to do is start expanding that last part and then a couple of sneaky little replacements and we'll have it. It's actually really not that bad. C squared equals H squared plus, how do I square a binomial? B minus X times B minus X. So that's H squared plus B squared minus 2BX plus X squared. Okay? Well, hold on. If I go back up here, X squared is the same as A squared minus H squared. Do you agree with that? I just took the H squared to the other side. Is that okay? Right? So C squared equals H squared plus B squared minus plus A squared minus H squared, right? Is that okay? And then the only other thing I need to get rid of is this X in here. And how can I do that? If I change this to A times the cosine of C equals X, I can replace this for X, and I get 2 times B times A cos C, and we're actually pretty much done. It was that easy. Like, it's not easy like you could have figured it out on your own, but it's only a couple of steps of algebra. And it's all stuff that you've done and you know how to do in grade 10. H squared minus H squared, C squared equals, there's my A squared plus B squared, right? Minus 2AB cos C. And there's your formula. Okay. I will put up the first couple of questions. There's our practice. And if you're still having calculator issues,